Hello, good morning, good afternoon. I don't know the time of the day that you are doing this lesson, but I hope that whatever time it is, you are having a great day. Okay, so we are here to do, of course, you know what we're here to do, another science lesson. And last lesson, I told you that we were going to talk about tectonic plates. So let's review a little bit. What did we learn about the Earth last time? It is made up of different layers. That's right. It is made up of different layers. And we specifically concentrated on the top layer, the outermost layer, which is called the what? Do you remember? Remember? That's right. The crust. So we found out, can you share some things that you remember about the crust, that outermost layer? Anything that you remember? Well, it is the thinnest of all the layers. I mean, not like this. It is kilometers and kilometers and kilometers deep, but it is the thinnest. What else do you remember? Anything else? Nothing? Okay, that's right. It's on top of the mantle. It is on top of the layer that is called the mantle. And do you remember the temperature? What about the temperature? That's right. It increases. The temperature becomes hotter as you get deeper into the crust. And we said that the crust is made up of dirt and rocks, right? Soil and rocks. And it is broken down into plates that we call tectonic plates. And that is exactly the target of our lesson today. Let's look at our learning target. I can explain two types of tectonic plates and plate boundaries. Okay, so the important part here is two types, okay? So there are two types of tectonic plates, and there is something else called plate boundaries, okay? So you know what a boundary is, okay? So today's lesson is all about tectonic plates. You know, what are these things? So last lesson we found out that the crust is made up of different plates, and we said it's not like a dish, but sort of like like a big chunks, big pieces, okay, of crust. And those pieces, those plates, are called tectonic plates. Now let's look at a map. Well, before we look at a map, let's look at the diagram of the Earth so that we can refresh our memory a little bit. Remember this? So the crust, the mantle, the outer core, and the inner core. Okay, I wanted to make sure that you remember that. So now let's look at a map. So here is a map. If we took the Earth and stretch it out, okay, here is a two-dimensional map. And I want you to take a look at this and see if you just write a few things that you notice. What do you notice about this? What do you see that you notice? What do you notice about this map? Okay, you can write anything. Okay. So things that you see. Go ahead and write down, what do you notice when you're looking at this map of our planet? So let's share some of those things that we noticed. Let's share some of those things. So I don't know exactly what you share, but I'm sure somebody said that they see a lot of blue, which means that there is a lot of water, right? And there are big pieces of land. We call those what? What do we call those big pieces of land? We call them continents. Continents. Okay, not counties, not countries, continents. All right? What else do you notice? There are different colors. there. So they represent, we're going to talk about those maps later, but they're different colors. And I don't know if you noticed something. Let me show you that map again. Look at those pieces. Look at the space over here. The space over here that goes. Doesn't that look like a huge puzzle? Doesn't that look like a huge puzzle? Well, it looked like a huge puzzle to some scientists, and they started wondering one thing. What do you think they were wondering? What do you think? Any ideas? Well, they were wondering if the Earth's surface, okay, always looked this way. And especially since it looked like a big puzzle, they were figuring, well, maybe at some point the Earth looked a little bit different. Maybe those pieces were more together. And especially there was this guy, okay, let me show you his name. Alfred Wegener. I don't know how to say that name. Wegener. But that name, okay? He started wondering that. And he said, you know, I think that the continents must be moving. Sort of like this. Kind of interesting, right? He said, I think the continents must be moving. Let me show you one more time. They're moving apart. Interesting theory. But they were not too sure about this theory. They just knew that something was going on. However, you know, something else they realized? Let's read over here to see what they found out. So in the 1950s, scientists discovered that molten rock from the mantle was rising to Earth's surface in the ocean basins. As this rock cooled and hardened, it was being added to the Earth's crust. So molten means melted. So they realized that there was a melted rock from what is that layer? Under the crust, do you remember that name of that layer? Come on. From the mantle, that's right, was rising up through the ocean floor, and when it hardened, it became part of the crust. How was this happening? They came up with a theory, which is called plate tectonics. The idea that plates of rock moving slowly across Earth's surface is called plate tectonics. As you might expect, the plates move very slowly, okay? Their average speed is about 10 centimeters or 4 inches in a year. However, over millions of years, plates can move thousands of kilometers. And here is a diagram of what scientists think that these plates look like and where they connect. So look over here, there is one plate, okay? Another one here, another one here, another one here, 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 and here. So you got to remember that these plates make up the crust. And on the crust, there is only land? Only water? No, on the crust, there is both land and water, okay? So on the crust, there is both oceans and rivers and lakes and also lands, continents and islands, okay? But all of these oceans and all of these continents are on top of those plates, okay, that are moving slowly. So scientists even come up with a name for that big piece of land that was all together before. You see, Africa, South America, North America, okay, Europe over here. And so they think that all of those continents were together. And as the plates move, okay, as the plates move slowly, then those continents separated to look how it looks today. Let's look at our learning target to make sure that we are covering this. So I can explain the two types of tectonic plates and plate boundaries, okay? So let's read a little bit more from the article that we were reading together. So over here it says, there are two kinds of plates. Oceanic plates. Oh man, the light came off. One moment, please. All right. Yeah, so oceanic plates consist almost entirely of dense ocean floor material. And continental plates are made up of lighter continental rock, okay? So the two types are oceanic, and I think you should write that in your notes, oceanic. So they consist almost entirely of dense ocean floor, and continental plates are made up of lighter continental rock. Okay, so those are the two types of continental plates. Those are the two types of tectonic plates. Excuse me. So those are the two types of tectonic plates, oceanic and continental. Oceanic has to do with oceans, so the ocean floors, and continental has to do with continents. Okay? So if those plates are moving, if they're moving, sometimes they're moving apart, but sometimes they're coming together. Right? Remember that some scientists realized that there was some melted rock coming through from the mantle and then becoming hard, and then that stuff became part of the crust. Okay? So let's look at three types of plate boundaries. Three types of plate boundaries. So let's look at those three types of tectonic plate boundaries. Okay, so one is called the converging boundaries, which is where two plates collide against each other. You see the two arrows? So they are converging. Two plates move toward each other. Okay? The second type is diverging boundaries, where the plates are moving apart. So here is a perfect opportunity for that molten rock from the mantle to come up. Remember, the scientists were seeing that in the ocean floors? Okay. And then the last type is a sliding boundary, where two plates slide past each other, moving in opposite directions. So if you have to go back and watch that part again, do it, okay? And make sure that you take notes on all of those three. So converging, diverging, and sliding boundaries, okay? So all of that is part of the crust. So now we know a lot about the Earth's crust, don't we? You didn't know that it was so complicated. We just thought, well, we just live on planet Earth. It's a lot more intricate than that. Let's look at review questions. So the picture shows Earth layers. Layer 1, 2, 3, 4. So what is true about the layer where humans live? Okay? It is made of solid metal. It is made of liquid metal where humans live, okay? It is the thickest layer. It is the thinnest layer. So where do humans live? Inside the Earth or on the surface? On the surface. So we live on the crust, and we know that the crust is the thinnest layer, okay? Where the continents and the oceans are. So now you know a lot about the Earth's crust, okay? And for next lesson, we're going to keep moving in to the next layer. What's the next layer? The mantle. So next lesson is going to be all about the mantle, okay? Until we get to the very center. So thank you so much. I hope that you have a great rest of the day. And I will see you next time. Bye-bye.